After building over 100 AI automations, I discovered what determines whether your AI actually works or just burns money. Most people think it's just fancy prompt engineering or a clear goal, but it's more than that. Today, I'll break down exactly what context engineering is, why it matters, and how to implement it with zero fluff. By the end of this video, you'll understand why context engineering is the next most important skill that you can learn if you want AI that actually works in production. So in this video, first, I'll explain exactly what context engineering is, why it matters, and how it's different from prompt engineering. I'll walk you through the complete framework with the 4 core strategies you need to know. Then we'll look at real implementation examples so you can see this in action. I'll show you the biggest mistake that kills AI projects so you can avoid them completely. And if you want to work with me for a functioning, comprehensive AI ecosystem with the right context engineering, book a call with me down below. Also, join my free school community, the AI Avengers, down below to network with other successful business and agency owners that are finding success with AI. Without further ado, let's get right into it. So first, let's start with a definition. Context engineering is a systematic approach to feeding the AI the right information in the right format at the right time. If prompt engineering is the art and science of writing the best instructions for AI to get the optimal output, context engineering is the art and science of preparing the best context for AI to produce the optimal output. It's about building dynamic intelligence systems that provide relevant context automatically. The goal is transforming AI from a simple Q&A tool into an intelligent assistant that actually understands your business. This will work for most areas in AI and tech today. So this won't just work for chatbots and voice agents. It's also going to work for internal AI agents for internal processes. And it's also going to work for vibe coding when you create apps. Here's a perfect analogy that makes the comparison between context engineering and prompt engineering crystal clear. Prompt engineering is like giving a doctor the instructions for how to treat patients in general. Context engineering is giving that doctor everything that they know about this specific patient, their history, their allergies, their symptoms, their previous treatments, and current medications that they're on. Prompt engineering focuses on single interaction optimization with general instructions. It can be tailored to this specific business and use case, but it's high level. Context engineering provides system level intelligence with patient history and specific context for each situation. The key insight here is that no two patients or business situations are ever identical. You can't solve unique problems with generic one-size-fits-all solutions. This is what's happening in most businesses implementing AI right now. The AI agents that they implement have zero memory retention. AI forgets everything after each interaction. It's just like how customer support chatbots. They forget everything unless you tell them everything or they provide their order number. Every conversation starts from scratch, which creates a fresh problem where customers have to re-explain everything every single time. This leads to massive inefficiencies and wasted resources, time and money lost to repetitive explanations that could have been automated. Let me go through an example where prompt engineering isn't enough. Imagine building a customer service refund system. You create this massive prompt with a lot of instructions together. Check the 30-day window, validate warranty rules, determine product category, calculate taxes, calculate the final refund amount after restocking fees, etc. There's a lot of factors to put in. There's a lot of things to factor into the system. The AI gets overwhelmed by information overload. It forgets warranty rules, it mixes up product categories, ignores tax calculations, starts hallucinating. The core issue is simple. You're asking a single agent to handle multiple responsibilities that should be managed by an intelligent system. You're basically expecting craftsman-level performance from a one-size-fits-all jack-of-all-trades. As you all know, jack-of-all-trades is a master of none. There are 3 critical limitations in real business scenarios. Firstly, informational overhead. Think about how human attention works. When somebody gives you a 20-page instruction manual and asks you to memorize it before handling customer calls, your performance level goes down. AI models face the same limitation. As prompt length increases, the model's ability to prioritize and focus on relevant instructions decreases exponentially. So in practical terms, a 500-word prompt might look fine for simple tasks. A 2,000-word prompt handling multiple scenarios starts showing inconsistency. A 5,000 or 10,000-word prompt trying to cover every single edge case and every single instruction and role becomes unreliable because the model can't maintain focus across all the competing instructions. And secondly, there's higher costs. So the longer your prompt, the more input tokens are involved. The prompt is the input, and it's made up of tokens, which is around 3/4 of a word. The longer the prompt, the more expensive the input token is, and that leads to increased expenses and latency. The more information that the AI has to process, which leads to higher latency. So longer prompts require more processing time, which increases latency. And customers wait longer for responses, and your operational costs increase. So you're effectively paying premium prices for non-premium speed. And the third reason, more confusion. This is the priority paradox. When you pile multiple instructions into one prompt, you create competing priorities without clear resolution mechanisms. Be helpful, but be brief. Follow policy, but make exceptions for VIP customers. Be thorough, but be efficient. So they kind of contradict each other, you know? So the AI, it can't resolve these contradictions intelligently because it lacks the contextual framework to understand when one instruction should override another. So it either defaults to rigid rule following that's extremely ineffective and efficient, or it makes inconsistent judgment calls that frustrate the customers and the support team and the business. So modern AI systems that actually work in production look fundamentally different from what most people build. So it follows the 80-20 rule. 80% is made up of dynamic context, which includes the customer's current situation, their history with your company, relevant policies for their specific case, real-time inventory data, and current system status. So this information, it changes for every interaction and gets assembled. So this is basically real-time relevant information. And 20% is static instructions. So these are your traditional prompt engineering. So it should only contain core behavioral guidelines that never change. So things like maintain a professional tone and always confirm understanding before taking action, or escalate to humans when you're uncertain about certain issues. If you haven't watched my prompt engineering video yet, you can check it up over here. And anyways, so basically static instructions, it's prompt engineering. So it's 80% context engineering, 20% prompt engineering. So the reason this works is static instructions, it provides consistency. So it ensures that the AI always knows how to act, and dynamic context provides relevance. So the AI always has the right information for the current situation and knows how to act accordingly. So the AI isn't trying to memorize every single possible scenario or trying to memorize an entire textbook. It's applying consistent principles to dynamic information. And context engineering, it doesn't eliminate prompt engineering. It makes it more effective, in fact. So your prompt, it can become shorter, it can become more focused and more reliable because they're working with relevant, well-organized information instead of trying to handle everything through raw instruction. You don't have to put every single information about this specific business into the prompt and just instruct the AI agent in the prompt to use RAG to get information whenever it's necessary. So relating back to the doctor-patient example that I mentioned earlier, so you can think of prompt engineering as teaching a doctor how to diagnose illnesses, prescribe medicine, and perform surgery. And context engineering is giving them information about the patient, symptoms, illnesses, history, and their medication. So both are necessary, but neither works well without the other. So now let's dive into the context engineering framework. These are the 4 core strategies that make context engineering work. So writing context means saving information outside the context window for later retrieval. Selecting context means pulling only relevant information for the specific step. So for example, a customer service agent doesn't need to know about warranty during the first point of contact when they need to understand what the problem is itself, or if it even involves warranty in the first place. Compressing context means summarizing while preserving key details. So the thing is, nobody wants to read a whole textbook or a paragraph with 100 lines, right? You want to make it concise and easy to read. AI feels the same way. So we want to make it as efficient and easy to go through as possible. Finally, isolating context means preventing task interference between different functions. So we want everything to be as siloed and independent as possible. So we don't want anything to overlap. We want to minimize that. And I'll go over each one of these in detail. So each point in this context engineering framework addresses specific technical and business challenges in AI system design. The first point, writing context. So this solves the fundamental persistence problem. AI models are stateless by default. They literally forget everything between interactions. And once the session is over, it starts from a new slate. It gets reset. And writing context, it creates an external memory system where important information gets stored and retrieved intelligently. So here's how it works in practice. So you could think of it as scratchpads. They function like the AI's notepad during complex tasks. When analyzing a customer refund request, the AI documents its reasoning step by step. So the customer purchased the laptop on March 1st. Today's March 20th, and therefore it's within the window for a refund. And it's in the electronics category, so the warranty applies. Hardware failure reported qualifies for a full refund. This isn't just logging information, it's structured reasoning that the AI references throughout the conversation. And this builds long-term memory. It builds persistent knowledge about users, their preferences, and problem resolution patterns. The system learns customers mentioning slow startup usually have storage issues, not memory problems, and discovers that offering store credit increases satisfaction by 40%. This institutional knowledge accumulates and increases performance over time. Selecting context. So this is relevance. And this solves information overload by intelligently retrieving only what's relevant for the current task. So instead of dumping everything onto the AI's context, you build systems that understand both your user's requests and available information sources. Smart retrieval requires understanding semantic relationships. So when somebody asks about laptop battery life, the system retrieves power management information, so usage optimization tips, performance data, not general laptop specifications or battery chemistry details. So when it sees a keyword, it immediately knows what information is required, not just any information, the relevant information. And the tool selection prevents capability bloat. So if your AI had access to 50 different functions, but somebody asks about shipping status, it should only consider the few tools related to order tracking, not email functions, not calendar tools, not billing systems. This requires intelligent routing based on intent recognition and only giving it the right tools for their specific task. If it's not relevant to them, don't give it to them. Simple as that. So basically, you want to optimize the knowledge base so only the right information is found and only when it's necessary. And compressing context is all about efficiency. So this solves cost and performance problems when conversations get long or information sources become extensive. Compression preserves important information while reducing token usage through intelligent summarization. How does compression work? So recent interactions, they stay fully detailed because they're the most relevant. Last week's conversations, they get compressed to key outcomes. So resolved billing inquiry, customer satisfied, no follow-up needed. And last month's interaction becomes a pattern. So the customer prefers email. James prefers to be called Jim, and Jim typically likes to ask technical questions. Token optimization isn't just about cost, it's about cognitive loads. Compressed context, it allows the AI to see further back in time without being overwhelmed by irrelevant details. So you want to consider how much information that the AI agent or the AI system requires. So if it's like a chatbot for new leads, then it doesn't need to know things that happened like 20 years ago. And finally, isolating context. This solves complexity problem by creating specialized environments where different types of processing happen without interference. So instead of building one system that handles everything poorly, each isolated context gets optimized for specific purposes. Multi-agent systems prevent task interference. A customer service agent and technical diagnostic agent, different information, different tools, and different response patterns. Isolation prevents the customer service agent from getting confused by technical procedures. It's kind of like how when you call up a business, you want support with billing, then they're going to transfer you over to the billing department. If you're having a technical error, the billing department is going to transfer you over to the technical department. And if you're overdue on late fees, they're going to transfer you to the billing department or to the debt collection. Session management ensures that conversations with different users don't contaminate each other. Each customer is isolated and they don't overlap in any way. And poor session isolation causes AI systems to mix up customer information. That leads to confusion, and nobody likes that, right? So these strategies work together. You might write context in one specialized environment, select relevant pieces in another, compress them for efficiency, and isolate the final processing to prevent contamination. Each strategy addresses different aspects of information management, but they combine to create intelligent systems that remember, learn, and stay focused on what actually matters. Memory architecture determines how effectively your AI system can learn and adapt over time. Working memory is the active processing layer. It holds the information that's currently being processed. This includes the user's current request, relevant context that's been extracted, intermediate calculations or reasoning steps, and how to respond. So it's basically information that's being actively used right now. Short-term memory maintains conversation continuity within this single session. It includes what the user has said, what the AI has responded, any decisions that have been made, the current state of any ongoing tasks. So it's recent conversation history within the current session. Long-term memory is persistent knowledge across multiple sessions. So this provides persistent value that improves system performance over time. This includes user preferences and patterns, successful strategies, FAQs and effective answers, and optimizations for common scenarios. And the way you can store long-term memory is Google Docs works very well for simple implementations, but as you get more information to process, you would want to start using vector stores and vector databases like Supabase. And you can also use CRMs like Go High Level or Salesforce or HubSpot to store customer information and to retrieve information from there. So the choice depends on your specific use case, technical infrastructure, and team capabilities. So the key is ensuring that the stored information can be efficiently retrieved when it's relevant. I've already been over RAG, which stands for Retrieval Augmented Generation, in a previous video. If you haven't checked it out yet, go check it up over here. But anyways, just think of it like this. It's very simple, just 2 steps. So step 1 is AI retrieves the relevant documents or data or the information at the query time. And then step 2, it's AI generating the more accurate response using that information to fill the requests or to answer the customer's inquiries, something like that. And a very simple analogy is like a librarian trying to find the exact book that you need. So even if you forgot the name of the book or the author, if you remember the plot of it or like the name of a character, the librarian will recognize it and will find that exact book for you. So RAG is just like that. The AI doesn't just rely on what it was trained on. It actively looks up current relevant information to answer your specific question. And here's how RAG works in real business situations. So vector databases provide semantic search through company documents and knowledge bases. API integration gives you real-time weather inventory levels and customer data access. Internal systems connect to CRM contexts, Google Sheets, and project management tools. Web research pulls current news, current information, competitor analysis, and market data. So the key principle here is that AI accesses only the relevant information, not everything. This prevents information overload while ensuring accuracy. A production-ready context engineering system requires all 6 of these components working in coordination. The user input analysis goes beyond simple text processing. The system needs to understand the intent, what the user actually wants to accomplish, context rules about the user's situations and constraints, implicit information that the user assumes but doesn't state, and understand nuances and urgency indicators that affect how the request should be prioritized. And effective input processing prevents misunderstandings that lead to frustrating interactions and wasted resources. System instructions sets core behavioral rules and guidelines and establishes consistency in behavior across all the interactions. So this includes communication style guidelines that ensure appropriate tone and professionalism, ethical boundaries that prevent harmful, inappropriate responses, and the appropriate escalation criteria that define what can be done by AI and what has to be handled by a human. As you know, nothing is perfect just yet. Nothing is bulletproof. So some things, they just have to be handled by a person, and the appropriate quality standards that maintain accurate responses and helpfulness. And then there's memory systems. So short-term conversation and long-term knowledge memory must work together seamlessly. So short-term memory provides conversation continuity within sessions, and long-term memory, it enables personalizations and learning over time. Knowledge retrieval systems, it must balance comprehensiveness with efficiency, access all the relevant information, prioritize information based on the relevance, and integrate information from multiple sources whenever it's necessary and do it well. And also it needs to present information in an appropriate format and tools and actions that enable AI systems to accomplish tasks beyond conversation. So yeah, this includes like data manipulation, API integrations, like updating and searching records, calculations, communication tools like emails, SMS, WhatsApp, etc., and output structure. And finally, having a consistent output structure ensures that AI responses meet user expectations and system requirements. So for example, like phone numbers, they should always be in like E164 format or something. And emails should always be a company email, not like a Gmail or a Hotmail. for example. And if I illustrate it on an AI agent, so as you can see here, so this is the user input, the AI agent, and this is the instructions. This is where the prompt engineering magic happens, and super base vector store. So this is the long-term memory, the RAG knowledge base. And simple memory, this is the short-term memory, and it's defined by the session ID or the user's phone number or the user's email. So if it's an interaction by email, then the ID in the simple memory, it's going to be the user's email. So it's going to be able to search up previous conversation history by the email. Or if it's like a WhatsApp, it's going to be able to search up previous conversation history by the WhatsApp phone number. And this is the LLM. So this is OpenAI ChatGPT to process all the information that comes in and goes out and send a message in Gmail. So this gives the AI agent the ability to send an email on Gmail. And here's your simple 3-phase approach for a successful implementation strategy. So phase 1 is about the basic memory. So start with conversation continuity within sessions. So implement a simple memory session that stores the last 5 or 10 message pairs. Set up session ID management using the email address for an email agent, phone number for SMS or WhatsApp agent, or unique user ID for an app. So for example, if a customer says, I'm having trouble with my order, that your AI should remember that they mentioned an order issue and not ask it to repeat it 3 messages later. It should be able to look up the record by looking up their order ID. Phase 1 is achieving 0 forgotten context within a conversation. If a customer has to repeat himself in the same session, then you failed. You can't go on to phase 2. If that problem doesn't happen anymore, that's when you can go on to phase 2, which is smart retrieval. So this is where you can finally connect your existing business systems to your AI system. So this isn't about building new databases. It's about using what you already have and integrating them seamlessly. So connecting your CRM for customer history, your knowledge base for policies, Google Sheets, or Shopify for product information. And the key here is to implement long-term memory. And you do that with vector stores, which enable semantic search, like Superbase, for example. A quick example is when somebody asks about the return, don't just pull out the return policy, pull out their specific purchase history, their product warranty information, and any previous return requests. So it should have the right tools to pull out all this information and also have the right knowledge base to be able to pull out the relevant information from the knowledge base. And then once you're able to do this, then you move on to phase 3. Once you've achieved smart retrieval efficiently, you can move on to phase 3, which is advanced systems. So this is where you go into multi-agent specialization and complex workflows. So this is where you implement cost control and specialized agents. You deploy separate agents for different functions. So one for lead qualification, one for customer support, one for technical questions, one for billing, etc. And the critical mistake I see is that agencies, they're trying to jump straight to phase 3. You need the foundation first, or you're building on quicksand. The success formula is simple. Start simple, measure impact, scale systematically. Don't try to build everything at once. AI specialization is crucial for success. Focus on excellence through specialization. One AI agent equals one job done excellently. So use an assembly line approach with specialized agents rather than having one super agent attempting everything. So it's like in the military, there should be one soldier for controlling the tank, one soldier for the sniper, one soldier for flying planes, one medic, etc. It should be a team of different roles, and it's the same with AI agents. This enables optimized prompt engineering with better, more focused instructions for each specialized task and role. You also get model flexibility, where you can test different AI models for different functions. So for example, you can use separate agents for research, writing, customer service, lead generation, rather than trying to make one agent do everything poorly. And this principle will make or break your AI implementation. And here's why most people get it completely wrong. I constantly see agencies and businesses trying to build one AI agent that handles everything: customer service, sales, technical support, billing questions. It's like hiring one person to be your accountant, marketing director, and software developer. They'll be mediocre at everything instead of excellent at anything. Anyways, I'll give you a real-world assembly line example. This is my proposal generator. So this is like the main agent, the manager that makes sure that all the work is being done, and he delegates the task to these two agents right here. So the email agent writes the email, and the proposal agent writes the proposal. This is my proposal generator that I use myself. It's my previous video, and if you haven't seen it yet, go check it out right here. But anyways, this should help you understand what an assembly line AI agent approach is. And also, here's something that a lot of people miss. You can use different LLMs for different agents. GPT works better for customer service agents, and Claude works better for coding. So with multiple specialized agents, you can optimize each one individually and choose the appropriate LLMs and tools. So when each agent has one job, your prompt becomes much more focused. So instead of a 2,000 word prompt trying to cover every single little scenario, you get a more concise prompt that's laser targeted. It means better consistency, lower costs, easier debugging when something goes wrong, and lower latency. I'll quickly walk you through each of these common mistakes when it comes to implementation of context engineering. The first is information overload. So I've already talked about this, but trying to load every single thing into the context window when the context window is limited, and it depends on the model, but it's not infinite. If you try to load every single thing in there, well, the AI agent's going to get confused. Imagine throwing all these different textbooks from different subjects to an engineering student and expecting them to learn everything. It's not going to work. Simple as that. Only provide what's relevant and in the right length. Number two is a stale data pipeline. So the information must be accurate and up to date. Well, I've been over this many times, but garbage in equals garbage out. Your AI systems and your tech is only as good as the data that it's trained on. So if your data is trained on something that's completely irrelevant and something that happened like 40, 50 years ago, it's not going to be relevant today. Simple as that. And the third mistake, trying to make generalist AI agents instead of specialized AI agents. So just remember the principle, one agent, one role. And the fourth mistake is cost blindness. So this is a major issue that many companies and many agencies come across. So they ignore token costs and context limits. Context windows do have limits. They're not infinite. And also you have to take into account both the input and the output tokens. So how much information that you put in, it not only affects latency, but it also affects the cost as well. So the more information that you provided, it needs to process more information, right? So that's going to incur more costs. And the output, if it's very high volume and it provides very large outputs, it's going to cost a lot of money, right? So make sure that you monitor your token usage. I've seen monthly costs go from $100 to like thousands because an AI system was processing irrelevant context. Set up monitoring from day one and know your cost per conversation, cost per customer, cost per resolution. And the fifth mistake is no validation, missing validation layers for memory updates. AI systems learn from interactions, but what if they learn the wrong information? I've seen customer service bots that learned the incorrect policy information and they started giving out wrong answers. And there were cases of chatbots providing unauthorized information to customers. And that's why you need validation layers and security checks to prevent incorrect information from going out. Understanding these four context failure modes prevent your AI systems from catastrophic system failures. So first one is context poisoning. So this is kind of like a virus. So here's how it happens. Your AI customer service agent misunderstands a complex return policy. It saves this misunderstanding to memory. Over the next week, it references this wrong information in 50 customer conversations. And each conversation, it reinforces the error. Now you have 50 customers with the wrong expectations and an AI system that's confident in incorrect information. And you prevent this by implementing validation checkpoints where important information gets verified before being stored into memory. So use confidence scoring. If the AI isn't sure about something, flag it for human review. Always have a human in the loop. And the second one is context distraction. So this is when the AI is overwhelmed. Research shows that AI performance drops significantly after processing 100,000 tokens. I've tested this with a client system and with my own system, and at 50,000 tokens, accuracy was around 94%, but at 150,000 tokens, accuracy dropped significantly, I think to around 70%. And AI started repeating actions instead of reasoning about new situations. So the longer the conversation gets, the less accurate that it becomes, the costs go up, and customers get frustrated with repetitive responses. You need to fix this with aggressive summarization and relevance filtering. Third one, context confusion. It happens when relevant information pollutes working memory. Like I said earlier, many times, you need to only provide the relevant information and discard everything else. So isolate all the irrelevant information and only keep the relevant information. This prevents confusion and frees up the working memory. Finally, there's context clash. This is when different parts of the context contradict each other. For example, if the knowledge base says you have to do this way, but the product manual says you have to do it that way. The AI agent is going to get confused. Even a person would get confused. It would be like, do I do this or do I do that? It's going to create confusion, and that's what you want to prevent. Understanding these helps you build systems that avoid common pitfalls. Key takeaways. First, context engineering separates AI that only sometimes works versus an AI system that always works. Second, you need to master the 4 core strategies: select, compress, and isolate context systematically. Third, use the right implementation approach. Start simple, measure impact, scale systematically. Fourth, avoid the 4 failure modes. Prevent poisoning, distraction, confusion, and clash. So that was it for this video. I hope you found it useful and understand context engineering now. If you have any questions, drop a comment down below and I'll be happy to chat. If you're a business owner ready to implement comprehensive AI ecosystems with excellent prompt and context engineering into your business, book a call with me down below. We'll analyze your current setup and show you exactly how to implement these strategies and systems. If you're an aspiring AI entrepreneur who wants to learn how to start and scale your AI agency, fill out the consultation form down below and join my free school community, the AI Avengers, down below to learn more about the AI systems I build and to network with other successful business and agency owners that are already using AI. That's it for this video. See you next.